What's up, everybody? Welcome back. So, we're gonna have a new episode in the AI Guard series today. I know it's been way too long since we worked on it, but I had some stuff going on. But I do plan on finishing the series, so we're gonna continue today. We're gonna add some attacking behavior to the behavior tree, and then in the next episode, we're also gonna add some logic to find cover and attack us from a cover location. And by then we should have a pretty simple guard setup that can actually take cover and attack the player. So we're gonna just keep working on the series. First of all, let's have a look at what we left with. So we have the guard set up and he's going to start firing, and we were pretty much testing the firing and adding new weapons. So this is where we left off. And first of all, we want to make sure that he doesn't just start firing at us. So we want to go to our weapon component inside of the data folder and open it up. There we go. And if we look at the event graph, all the way at the end of the begin play event, we have it set up so he will start firing at us over here. The delay for 3 seconds and then the fire weapon stuff. So we're going to delete that. And then we are good to go over here. There is one small thing I want to take a look at since we're already in here. If we look at the event fire weapon loop over here, we have this bool set up that will tell if we actually fired the weapon or not, and if we didn't fire it, it's going to stop the function. But we're not actually using it since we just have the bool set to true inside here. So let's just get rid of it. We're going to delete the branches over here and also delete those bool setters, and we can actually remove the outputs from the function as well for both the projectile and the trace weapon. So that was something I had set up but wasn't really useful, and well, we're just not going to use it. So for the projectile, we do want to make sure that we hook it up over here, as I accidentally deleted the reroute node. Okay, so that should be good to go. Let's compile and save this. And now let's start working on the actual attacking behavior inside of the behavior tree. So we're going to go to the behavior folder and I'm going to open the behavior tree. So that way we have access to the blackboard and the behavior tree at the same time. And the first thing I'm going to do in here is add a new key, and that's going to be a boolean is attacking. And we also want to add a second key, and that's going to be an object key. And we're going to call this the player to attack. And we want to make sure that we set this to an actor. So if we have it selected on the right side, we can go to the key type and then simply select actor from the drop-down list over here. And with those inside of our blackboard, we can take a look at the current behavior tree. So let's open that one up. And if we go all the way to the right, we have a delay in here for 10 seconds. So let's just get rid of that. We don't need it anymore. And then we want to add a new sequence where we have our attacking state. So over here we have the current state equal to searching, equal to chasing, idle. So we're just simply going to add a new sequence all the way to the right over here. So that's a composite, a sequence. And we're going to add a decorator, a blackboard-based condition. And we want to make sure that our current state is attacking. So we're going to select the current state over here is equal to, and then simply select combat, attacking combat. I'm sorry, it's been a while. And so that should be good to go. Then we also want to make sure that let me double check. Oh no, that's good to go, sorry. So then we're going to drop down from here, and we want to make sure that we change the move speed. So when our AI is attacking, we probably want him to move a bit faster, at least not just walk around. So we're going to change the move speed, and I'm going to set it to 400 over here. And the next thing we want to do in here is actually create an environmental query to see if we can attack a player or not. Am I correct about that? Yes, I am. Checking my notes. Yes, I am correct. So what we're going to do, we're going to create the environmental query. Let's get rid of this for now. Go to our EQS folder, right click, artificial intelligence, and create a new query. So I'm going to call this the environmental query can attack and open it up. So previously we often worked with a grid, so a points grid or a pathing grid or maybe a circle or a cone, something like that. This time we're going to create items around all actors of class. So we're going to select the actors of class, and in here we want to select the player character in your project. So in my case that's simply the third person character. And we can also specify a radius, so I'm going to increase this, or you can simply disable the radius and it will get all of the actors in the level. So for optimization reasons you might want to use this or not, but I'm going to set it to 8000, so then at least we are pretty sure we have some actors inside of our radius. The first thing we are going to do in here as a test is make let me see, a trace test. So we're going to right click and go to trace. We want to know if we can hit the player, so we're simply going to trace to all of the third person characters. And we're not going to use a line trace, but we're going to use a sphere trace, simply because we want to have a little bit of clearance around corners and objects. So if we use a line trace, then we can also hit the player in the elbow while we can't see the AI, for example. So we want to make sure we have a little bit of clearance, and that's why we're going to use a sphere trace instead of a line trace. So let's look at the trace data over here. The trace shape, we're going to set it to sphere. And then I'm going to use a radius of 45. Now we want to make sure that this only filters and doesn't score. So all the players that we cannot hit, we're simply going to filter them out. And we want to make sure that the bool match is set to false. So the line or the sphere trace doesn't hit anything, and that means we can reach the player. So if the trace actually hits geometry, then it will be filtered out. So that's the trace. And then we're simply going to add a distance check as well. So right click, go to distance, and we want to know the distance from the third person character to the querier from the trace. So that's already good to go. And in this case, we're not going to filter, but we're only going to score. So right click on the drop down and select score only. Now we can simply use the 3D distance, that's fine. We do want to change it to an inverse linear. So right now it says prefer a greater distance, but we actually want to prefer a smaller distance. So we're going to attack players that are closer to us, or at least prefer them over players that are further away from us. And then there's one more test that I want to add, and that's a dot. So we're going to add a third test, the dot. So the dot is basically like comparing two angles to each other, and the result of that will tell you if the players are facing each other, or the player is behind me, or to the left or to the right. So we want to prefer players that are in front of us, where we're already looking at, because that makes the most sense. So we're going to use the querier rotation. That's the rotation of the AI guard. And we're going to compare that to the rotation from the querier to the item. So the item in this case is the third person character, because that's where we created the items. So this is actually pretty good to go, but we do want to make sure that we don't filter. So we're going to set it to score only. And then we want to inverse linear over here. So it will be, if it's closer to 1, then we actually prefer that player. And if you're familiar with a dot product, if the result is 1, that means the player is directly in front of us. If the result is 0, it could be to our left or our right. And if the result is -1, then the player is behind us. So this simply makes us prefer players that are already right in front of us. Okay, so that's pretty much all we want to do for now. So I'm going to save this environmental query. And we need a bit of other stuff to make this work with our guard. So let's close this down. And we want to go to our interface for the guard. So I'll need to double check where that was again. The AI player pawn interface. Let me double check. No, because that's the player pawn. So we want the boom. I don't even know where we put it. Oh, I'm sorry. So inside of the behavior folder, we have the BPI AI pawn interface. So that's the pawn of the guard. We want to open that one up. And in here, we're going to create a new function. And that's simply going to be AI attack player. And I'm pretty sure we don't need any inputs in here. Let me double check. No, we're simply going to keep it like this. So we can compile and save that. And get rid of the interface. And we also need a behavior tree task. So from the behavior tree, we can tell our pawn that we want to attack. So we're going to create a new behavior tree task as well. Let's go to the behavior tree task folder. And I'm just going to duplicate one. And let's call this BTT attack player. Yep. And let's open that one up. So in here, we want to call the interface function that we just created. And we're also going to set our isAttacking bool to true in our blackboard. So we can get rid of all of the stuff that's in here because we duplicated it. And we don't need any of these variables either. So there we go. The first thing we're going to do is grab drag of the controlled pawn. And we want to get the blackboard of this guard. So get blackboard. And from the blackboard, we want to set a value as bool. So set value as bool. And in this case, we want to set our isAttacking bool. So we're going to drag off the key name and make a literal name. And that's our isAttacking boolean. So make sure there's no spelling errors and it actually matches our bool over here. Let's go back, and we want to set it to true, so enable it. And then we're going to call our interface function that we just created. So we want to drag off the pawn again, and then simply call our attack player. So the message function from the pawn interface over here. Plug it in as well. And then we can finish execute. And we want to make sure that we enable success. So the task actually always is successful in this case. It can't fail. Okay, compile and save that one. And with that stuff in place, we can go back to our behavior tree and set it up. So let me switch my nodes as well. In here, we want to drag off. And we're going to run our EQS query. So go to tasks and then run EQS query over here. Have it selected, and then on the right side we're going to choose our can attack query. And for that we want the single best item as a result. So that's good to go. We do want to make sure that we add a decorator in here. And again, that's a blackboard based condition. And this is to prepare for later. So we're going to select this, and we want to make sure that our player to attack is not set. So there's actually no player to attack defined yet, and we're going to find it using our EQS query. And then we also want to right click, add a decorator, and use a force success. So this part over here can't fail because we're using a sequence. And if one of the children fails, the actual entire sequence will abort and the behavior tree will re-evaluate itself. So we can use a for success node to create an optional branch inside of a sequence, and even if this fails, the sequence will still continue. Okay, so we have that part set up, and then we want to drag off here again. And in here, we're going to add another sequence. So let's composite sequence. And for this, we're going to add another decorator blackboard based condition. And in this case, we want to make sure that our player to attack is actually set. So we're going to go to player to attack and then is set. And again, we also want to add a for success node in here. So let's make sure we do that as well. So if this query actually returns a player, it will set it. Okay, so that's good that I double check it. So we need to select the EQS query because we don't want it to set the self actor, but we want it to set the result of the query to the player to attack. So over here, select player to attack. And then if this query actually finds a player we can attack, it will be stored inside of this variable on the blackboard. And then we can go to our next sequence over here, and that actually only executes if the player to attack is set. So then we are good to go. Then we can drag off here. We're going to do a task, and that's our behavior tree task attack player. And then we're going to drag off here again, and we're going to use a simple wait. So you select a wait node from the task. We want to decrease the wait, so I'm going to set it to something like half a second. And then right click on here, and we're going to add a decorator, and that's going to be a conditional loop. Select the conditional loop, and in here we want to make sure that our is attacking bool is set. So we're simply going to wait for as long as our is attacking bool is true. This wait will execute, and only if it's set back to false, it will abort over here. But we have a for success over here, so it will fail at that point, but we will still continue executing our branch in here. Okay, so that's good to go. And then for now, we're gonna add a wait at the end. So we're gonna drag over here again, go to task, select a wait. And we're gonna wait for something like 2 or 3 seconds. And I'm gonna add a random deviation of 1 second to make it a little bit more random. Just for testing purpose, basically. So we can save this, and our behavior tree should be pretty good to go for now. So what we want to do next is make sure that our is attacking function from the interface actually does something on our pawn. So let's go to our guard over here, the pawn, and we want to go to the event graph, and I'm going to switch my nodes as well. So for the event graph, we want to implement our new attack player interface function. So simply double click it and it will be created. And the first thing we need to do is get the player that we want to attack, and we need to get it from the blackboard. So let's get our blackboard. And we have it stored on there as the player to attack, and that's an object key. So we're going to get a value as object. And again, we need to specify which key that's going to be. So we're going to make a literal name, and that's our player to attack. And again, make sure there's no spelling errors in here. So it will return an object, and we need to cast it to an actor because we need it to be an actor to be able to work with it. So cast to actor. And this can actually be a pure cast because we are pretty sure that it's actually an actor. So that should be good to go. Then we're going to set the focus to this actor. So we need to get our AI controller. And we need to hook in the controlled actor, and that's actually a reference to ourselves. And then we can set the focus to this actor. So set focus. And that's the first thing we're going to do over here. And plug in the player to attack. Now, I also want to use the aiming function that we have set up in our animation blueprint. And to make that work, pretty simple. We're going to create a new boolean for that. So create a new variable, call that isAiming. And we do want to make sure that this is replicated. So a normal replication, not a rep notify. So all of this Blackboard stuff only executes on the server, and this function is called from our behavior tree, which also only runs on the server. So that means this event will only execute on the server. So we can simply set the replicated bool over here and it will replicate to all of the clients. So that's good to go as well. Then I'm going to add a little delay in here for something like 0.7 or 1 second, something like that. So this simply warns the player that the AI is about to shoot at him. He's going to ADS and then wait for a little bit and then fire, so the player can actually react. You don't really need it in here, but I think it looks a little bit better. And then we simply want to fire our weapon. So we need our weapon component over here, the actual reference. So not the class reference, but the actual reference to the component. We're going to drag off and simply fire our weapon. Oop. Plug that in and set the bool to true. So that will make the AI start firing. And we want to know if the weapon that we are firing is automatic or not. So we're going to add a branch in here, drag off the weapon component, and we're going to get our is auto fire boolean and plug it in over here. Oop. So if it's an automatic weapon, we can wait for a little bit. So I'm going to wait for something like 2 seconds, and you can randomize the time if you want to. But for now, I'm just going to say 2 seconds. And if it's not auto fire, we're simply going to continue. And if this is done, we're going to grab our fire weapon node again, paste it in here, and make sure we connect both of the branches. And at this point, we're going to stop firing. So we're going to say, stop firing your weapon. But we do want to wait for the time that our is firing boolean is set. So not the auto fire, but the is firing boolean that actually runs for the entire loop while we are still firing the weapon. So for example, if we have a shotgun that has a fire time of 1.5 seconds because he needs to rechamber, it will take 1.5 seconds for the is firing boolean to be set back to false. And we want to wait for that because that's just how we set it up. So we're going to grab a branch and get our is firing boolean. Plug it in over here. And for as long as this is true, we're going to wait. So I'm going to add a delay in here, plug in the true pin and loop it back around. And then if this is false, we are actually done firing. So first thing I'm going to do is grab our isAiming boolean and set that back to false. And then we want to clear our isAttacking boolean on the blackboard again. So we're going to get our blackboard. And in here we want to set a value as bool. So in this case we want to set the isAttacking boolean. And we want to set it to false, so don't enable it like I just did. We're going to make a literal name and set our isAttacking boolean back to false. So that will make sure that inside of our behavior tree, the conditional loop will stop waiting and the behavior tree will actually continue running. And after that, we're also going to set our player to attack back to an empty reference on the blackboard. So we're going to drag off the blackboard again and we're going to clear a value. So in this case, it doesn't matter what kind of value it is. If it's a bool or an object or something like that, we can simply clear it and then drag off here, make a literal name. And we want to clear the player to attack. So the next time that our behavior tree actually starts running this sequence, then we can double check the player to attack and see if there's any other or better targets closer to us or directly in front of us that we want to attack next time around. So that should be pretty good to go. We can compile and save that as well. Now there is one small thing left to do, and that's make sure that our is aiming boolean actually does something. So let's close this down and open our animation blueprint. So if we look at the animation graph, we actually have it set with an aiming boolean already. We're simply not using it. So we can go to our thread save update animation function. And in here, simply grab a setter for the is aiming bool, hook it up at the end over here. We're going to drag off and use the property access system. And we can bind it to our guard is aiming boolean. So that's down here. Go to the guard and then scroll down, and over here we have is aiming. So that's the bool that we just created, the replicated one, inside of the attack player function event actually. Compile and save that. So that should make our ADS work, and then we should be pretty good to test this. So let's see what happens. So in this case, the AI actually needs to be in combat, so he needs to fully detect us. And that's right now, and you can see he will start firing at us as soon as we get detected. Now, he won't move around or do anything else, so it's pretty boring, but it is actually working. So what we could do, for example, is open our behavior tree. Let me double check. Oh crap. Okay, let me try that again. So if we open our behavior tree on the side, then you can see it's actually working. So this is really small over here, but we have the equal to combat state over here. So let me grab the viewport again. And as soon as the AI actually starts attacking, this should actually show it. Come on. Okay, so that's pretty much because I didn't have it open when I started playing, I think. So let's have it open over here, hit Alt P, and then it should work. There we go. So you can see it's actually using our behavior tree and the nodes that we created to engage this attacking state. So that wasn't really too hard, and it's not really exciting either, but we have something to start with. In the next episode, we're going to expand on this, and as I mentioned, we're going to make sure that the AI can actually go into a cover location, look for cover, and then from that cover location, step out of it and attack the player. So the next episode, we're going to wrap things up pretty much. Thanks for watching, thanks for your patience, and I'll be back a lot sooner with the next and probably last episode in this series. Talk to you later, guys and girls. Bye bye.